So we're now looking at day 3 of quadratics. And what you just discovered, which is, in my opinion, is the best shape other than the circle, is the parabola. Okay? So what we just discovered, and I want you to write this down on the paper that we just finished folding together. You're going to take really good notes on this, okay? And then, yes, you have paper notes that you'll add more to that. Is that I want you to draw this parabola right here that was created from folding this piece of paper the way we did. Okay. What really happened, and the reason why we were able to do this and make this happen, of all this folding the paper and whatnot, is that we discovered that any point on a parabola, there is a point called a focus, and this is the one that we made, that the distance from the focus, I'm going to use this, let's use it with green. The distance from the focus to any point on the parabola, the straight line distance, is equal to the straight line distance of this line that we created on our paper here. Okay. So this line that we created is very important. We're learning it today. I want you, and it's okay if yours is solid, but when we do like problems, homework, and quizzes, this is going to be a dashed line. Okay? And this dashed line is called the directrix. Okay. So now we have the focus and we have the directrix. We know something already called the vertex. Okay? And the vertex is going to be perfectly between the focus and the directrix. So let's say if I were to create some kind of line here, a straight line, like we can even say at a 90-degree angle, between that directrix and the vertex, this distance, whatever it is the same as this distance right here. Okay? So I'm going to go ahead and just draw this as a solid line, and I'm going to put these two dashes like you did in geometry to show that each of those are equivalent. And to highlight in purple, what I'm going to do is I'm going to use purple. There's a reason why purple. I'm going to use this purple right here, and I'm going to label this as P. We're going to look at that. This is called a focal length. Okay? So let me go ahead and do that right now. A focal length. It's the length between the focus and the vertex. Okay? Any questions so far from what we've done? Okay, so this is a parabola, and right here, off to the right, I'm going to put this a little bit darker, and I'm going to call this just a random point on the parabola. And you could have many of them, guys. You could have random points, like you could have picked one here, 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 here. It didn't matter. Whenever you pick one, if you go straight to the focus and you go straight to the directrix, those two, and I'll put them with the same hashes, those would be equivalent to each other. Notice how I did not put 2 on these, because if I put 2, then they would be equal to the p-values. Okay? So these are equal and these are equal. And yes, if I wanted to do one more set, just for instructional purposes, let's say that I picked one way out here, then this distance would be the same as this straight line distance that went straight to the directrix. Yes? Yeah, you can have mine. Alright, so what we are looking at today, the video that you just saw was using a parabolic dish. That satellite dish that the gentleman used in that video already had this shape. Guess what he put at the focus? Do you remember what he put? He put the pan, right? The pan. Because he was trying to focus all of the energy from the sun that was shooting straight from the sun, bouncing off, and going straight to the focus. And the thing is that the sun is shooting all of these rays that come straight from the sun and shoot to the focus. It could come straight from the sun and shoot and bounce to the focus. It could have come way over here and it will reflect and go straight to the focus. So all of that energy is harnessed and goes straight to the focus, which is why he could cook an egg out just in daylight. Now, we don't have the time, but we used to actually do this as a project, which now we do performance tasks and different things, but where students would actually build these. And they would come and they'd have these huge satellite dishes, and depending on the shape, they could use ellipses, they could do hyperbolas, they could do these parabolas. There was a lot of application with those, okay? And we actually did have students that would cook an egg, right? You just bring the skillet or whatever, and they would, on that skillet, suspend it or hang it some way or shape or form to where they could cook the egg right there at the focus. There's so much application with a parabola. This is just one. This satellite could be receiving communication from different countries. It could be receiving communication from outer space, from like spaceships, spacecraft, the shuttle out in orbit. Basically what it's saying is it will not only receive, but it can also transmit outward. So let's say that like there's a wire right here from the focus, and it goes all the way to, let's say, a nice pretty, that's my makeshift microphone, and here I am, a little bit of hair, just talking in the microphone, and I'm transmitting a signal that would just go all the way straight through the wire, and then from here we'll start shooting out into outer space. Okay? This is, and the curvature, the shape, the properties of the focus of the parabola allow this to happen. Okay? Any questions so far from what we've talked about? I'm going to put my hair back. Any questions? All right, so the equations. Let's do the math. The math that's associated with this is going to be not necessarily satellite dishes that are at an angle, because we know satellite dishes can be like at an angle and then kind of shooting outwards per se. But it's going to be a vertical or a horizontal parabola. Okay, so the vertical parabolas are going to look like this or this. Whoops. And the horizontal parabolas are going to look right, or they're going to look left. Okay? And the equations that you have affiliated with this are, this one is a y equals x squared family, and this one is an x equals y squared family. So your first equations that we're going to memorize and build these functions from, backward and forward, are going to be these. Here we go. We're going to say y is equal to ax minus h squared plus k. And this one over here is a horizontal one that we're going to say x is equal to a y minus k squared plus h. Notice that right here, this h is the x value of my vertex. So my vertex is hk. Okay? So the x value is where the h is at, and the y value is where the k is at. And just like we did with absolute value functions, everything in the parentheses we interpret what? Opposite. It's going to be the opposite sign. Okay? And everything outside of the parentheses, exactly what you see is what it should be. You follow the rules. Okay? So over here, I remember you from last unit. By the way, you guys did awesome on that test. You really did. I will give those back to you at the end of the class period today. Okay? You learned that everything with x, we did the opposite. I'm changing it up with you right now because it's still true per se. Because if it's with the x here, you're still doing the opposite. But now it's whatever's in parentheses is the opposite. Whatever's outside, you follow the rule. Okay, any questions before I continue? Because I know I have a lot of stuff up here. Yes?
So this is about the focus, but
Yep.
can it be anywhere? Or like is there a specific point?
That's the question. That's the most important question. And here's the thing. If the focus, let's say that I changed, so the focus has to be placed correctly. Because if you don't place the focus correctly, and you place it way down here, with this shape that you built, you're not maximizing the focus. You're losing energy. Think of it like you're on a phone call. You know how sometimes it's out of quote unquote focus. It's out of phase. You're not talking to the person because you can't hear them. It's because this is not in the correct spot per se. The best way to receive and send a signal is to put this exactly where it should be. So if I were to, let's say, open this up and make it wider, what do you think the focus would do? Do you think it would move further away or move closer? What would it do? It would move closer per se. Okay? Because as it moves closer, let's say it was here, now this distance is the same as that distance. So it's a very, very good question because if I built, let's say, this satellite dish, and I designed it, and I wanted to tell, like I was the engineer that designed this satellite dish, and I told the workers that were building it and putting it together, if I told them to put the focus here, it's a waste of money. That's a waste of a lot of money. I have to tell them exactly how much to measure, then to place the focus so that it's at the optimal both receiving and sending out signals, energy, whatever it is. And like this was, like there's many applications, okay? So we're going to do a problem here in just a bit to where, you know, clean power plants. Have you ever seen power plants? Probably not seen power plants with solar panels per se, but they have like these solar kind of reflectors. And it's clean energy. I used to live in California to where near Palm Springs, they had this huge field of thousands and thousands of windmills that with air would spin. And it was really windy around this kind of area because it was between this mountain range, like in a valley. And it would basically harness all that wind and it would create energy from these windmills. This is the same thing as far as, but it's with now a focal point. Guys, in the application of this, there's people who use this with lasers, either to do cataracts on your eye or eye surgery, or to reduce the size of a tumor possibly that might be cancerous. As far as with different things, there's so many different things that this is applicable to, and it all depends upon where's that focal energy located. Okay? All right, so with all that, the distance that we were just saying is important to create a well-balanced parabola. It is important, yes?
So the focus point and then like the stretch and like stretching of the parabola, like they go hand in hand to ensure like when it's like like when the line goes on, it'll go like straight up.
Perfect, yeah. So if you look at this, and I saw a couple of you whenever I was opening up and it moved further down, and when it closed up, it moved further away. I know that you wanted to get a little bit more clarity on that, and just to help you with that, let's think about this. If I have a parabola, here's the focus. And if I were to close the parabola, narrower, the focus moves away. Because ultimately, if I could close it fully, it would close to a circle, and it is a perfect center of the circle that is equidistant everywhere. That creates the radius of a circle. Okay, so that's what's kind of going on. Just if you were wondering, and I have not explained that to any other class, but because of the questions, that's where it kind of is related to. Okay, it's that balance. So let's go back here. The other equation that is big that I want you to memorize is, there's a relationship, is 4 times A times P is equal to 1. I can change this around. You'll see this on your homework. You'll see something that looks like this. A is equal to 4P. Guys, it's the same equation. I just got A by itself by dividing by 4P. Okay? And last but not least, there's one that you'll see on your homework and whatnot that says 1 over 4C. And I want you to right now and put in your notes, C is the same as P. Okay? But we're going to use P because P will work with everything. C only works if my vertex is at the origin. Okay? But we're going to make P work with everything because the vertex can move anywhere. Okay? It doesn't have to be at the origin. Now, I used to joke around, of course, and I'm recording, so I used to joke around and say, if you miss a problem, I'm going to give you one flat, whatever. As far as don't miss a problem, don't miss a math problem. But a good way to memorize this, another teacher told me, and I think I will use this, only because of the whatever boxing that has been going around, I don't want you flapping each other, is that 4 AP classes is equal to 1 tough year. Okay? So 4 AP classes is equal to 1 tough year is a lot safer analogy or whatnot, acronym for you to memorize this equation. But we will use this equation extensively, especially today. Okay? Any questions from everything that we've talked about? Yes?
So for the second equation where x is equal to, you would still plug in like the x and the y to where they go. Like that would switch?
That wouldn't switch, correct. It's just the way it's laid out, you'll see here soon, it's just a horizontal versus a vertical up and down. Okay? All right, so let's go ahead and go. We're going to go to our example problems immediately and see the application as far as what we are doing with these math equations. So let's go to right here. Problems 1A, 2A, so on and so forth. Okay, so now the notes part. What I want to do is, don't let all these letters throw you off. We're gonna of course look at the math, but I want you to think more of like the concept. Okay, so don't necessarily think of every little letter like I have to memorize this letter and so on and so forth. Just understand where the pieces belong. So the parabola is this piece. Just like if you didn't know it, a circle is not the whole thing. A circle is only all of these points. It's a set of points that are equidistant from a center. So when I say jump on the circle, if you jump here, you're not on the circle. Jumping on the circle means you're right there. So a parabola is what I shaded over here in gray. All of that is the parabola. All right, so let's keep going. It's subtle but important. The next thing that I'm going to shade is the focus of the parabola. And the focus is right there. Okay, and we talked about that with the circle. The more closed it is, the further away the focus is going to be. The more compressed it is, the closer it's going to be to that vertex. Okay. The directrix. The directrix is the line that is away from that vertex. So the parabola is always looking away from the directrix. Think of this parabola like an eyeball. It's looking that way. Okay? So it always looks away from the directrix. And those are for the more difficult questions that you're going to see. But nonetheless, this distance right here from the focus to any random point on the parabola will be the same distance from that point to the directrix. Okay? And then last but not least, the focal point, the P, is what this distance is between what two things? Not the directrix and the parabola. I mean, it could be, but it's more so the focal length is the distance between the vertex and the focus. That's why it's called the focal length, not the directrix length or length. Okay? Questions? Okay. So let's go ahead and go to the equations immediately and start building these. So again, these are those two equations that we were talking about, whether it's a vertical parabola or horizontal parabola, and you're going to see that C is the same as P. So just think of this, if you wanted to write it in your notes, as P and P. So in the notes that I just gave you before, I wrote something that looks like this. Oops. I wrote x minus h squared plus k. But that's not what they have here. I wrote a, they wrote 1 over 4p. Why? It's the same thing. If I look at 4 AP classes is equal to 1 tough year, and I solved for a all by itself, that means dividing by 4p, so those cancel. You see that I still have a is the same as 4p. So it's the same as what I put, only they wrote it in terms of p. I wrote it in a because you're really good at transformations, and I want you to see that compression or that stretch vertically immediately. Okay? All right. So let's move on. Whoops. Let's go ahead and go to our equation so we can see how we piece all this stuff together. All right, so go ahead and please close your Chromebooks now, and what I want you to do is follow me of what we do rather than follow the notes, because I want you to build this with me, and I'll call on you randomly, so please be ready, okay? All right, so close the Chromebooks, please. All right, so what is an equation of a parabola with the vertex at the origin and the focus at 0, 2? So the focus is directly above the vertex. Okay? This is the vertical parabola, so it's kind of telling you too much, with the vertex at the origin. And the focus is at 0c, otherwise what I would call 0p. And they're saying p is 2. Don't let them confuse you. This is where the focus lies. Okay? I'll start you off and then I'll call on you. Okay, here we go. The best advice that I can give you is draw it. If you can draw it and see it, it becomes a lot easier. So let's draw our vertex at the origin. And we're going to label, and this is what we'll give you group bonus points today, we're going to label it 0, 0. Then it says the focus is at 0, 2. So 0, 2, 1, 2, here is where the focus lies. And I'm going to color coordinate it for you so that when you go back, you can look at the notes if you'd like. Are we good? So now, I know that it's just asking for the equation, but I want everything. I want the equation, I want everything labeled, I want to do them all on all these problems, okay? So Raquel, in red, you tell me, where is the directrix? Perfect. Y equals negative 2 is the directrix. And anyone, I've asked you to draw that how? A dashed line. Here we go. Dashed line. Oh, we could do better than that. We're going to do a dashed line as the directrix here on the bottom. A nice, perfect, horizontal line that has a slope of 0, because if it's vertical, it's going to be a perfect one with a slope of undefined. Alright, so y is equal to negative 2. I'm taking care very close care because I want you to do the same. That's the Directrix. You with me? Okay. So now, opening it up, to me, yeah, you could try to eyeball it, but if you make it too steep and you don't show that these two are equal distant, you didn't do a good job of drawing the parabola. So what I want you to do first is I want you to come up with the equation so that you can draw the parabola much, much better. What is the most important equation do you think that I've shown you so far? Vertex form for sure, but what's the one that we will use all the time? The 4 AP classes equals 1 tough year. Okay, so we're going to go to 4 AP classes equals 1 tough year, and it's going to help us find A. Look, check this out. It's going to help us find A if they give us P. Or it's going to help us find P if they give us A. You with me? Which one did they give us? They give us P. What's P? 2. So 4 times A times 2 is equal to 8A. Anyone, what's A? 1/8. Now check this out. 1/8 is going to now go over here in my equation. And I know they have it basic. We would have it like this. AX minus h squared plus k. We know that our vertex lies at 0, 0. So these would zero out. They'd go away. And I would be left with this. We just found that A was 1/8. So it would create our equation of y is equal to 1/8 x squared. That's what we're going for. This is a vertical what by a factor of what? Vertical compression by a factor of 1/8. So you tell me, is it going to get narrow or is it going to get wider? It's going to get wider. Because the slope now is up 1 over 8. Up 1 to the left 8. So if I did that, I could draw a much better picture. So let's go up 1, and then we're going to go to the right. 1, 2, 3, 4, 5, 6, 7, 8. It would be about here per se. I know I'm a little bit eyeballing this and there. So now let's go to the left. 1, 2, 3, 4, 5, 6, 7, 8. And eyeballing it. That would be our parabola. Nice and balanced. Maximizing that signal that we are not only receiving but sending out through this shape. Like flashlights even follow this. Where the light is located on a flashlight, if it's too close or too far, it doesn't maximize the light that you could send out. Okay, and yes, sure enough, on any random point, like let's say this one, this distance would be equal distant to that distance. Just my scale is a little bit off right now because I didn't draw it a perfect scale. Are we good? Yes. Oh, I see what I just did. No, it's still good. Never mind. It's my scale that's off. That's why it doesn't look as equal distant. Say again.
I'm just confused on like how you know what the p-value is. Like, where did you get that from? Consistency.
So the p-value is the same thing as c, but it is from this equation that I've given you. So I've given you that there exists a relationship between a and p that will equal 1. Okay? So in this p-value is that distance from the vertex to the focus. This p-value in purple is this distance right here. See, and they gave it to us. They just called it C, but we're calling it P. Again, they called it C because they're saying C because it came from the origin, the center. But that's not what I want to use. That's not what we should use. We should use P, okay? Because my vertex will not always be at the center. I could have it shifted left 4 and then up 2 to where it could be way over here. I don't want that C to confuse you. I want it to be P because from that focus to the vertex, that is P.
So that distance will always be P.
That distance will always be P. And it will help you find this vertical stretch or compression of A or vice versa. You know what I mean? What do y'all think? Not too difficult, right? Joseph, do you have a question?
I thought that it was if it was 1/8 as A, then it would be the point would be 8/8 1/8 because it would go to the right one and then up 1/8.
So here's how you do it. I see what you're doing. He's trying to figure out why this wasn't the same as this per se. If there was something wrong in my drawing, here's what I'll say. If I go over 1, that means x is 1. That means I went to the right 1. You with me? What's 1 squared? 1. And then times 1/8. You see what I'm saying? Would be a y value of 1/8. So this point right here on the parabola, I went over 1. Anyone, what would be the y value that it would give me? 1/8. So I see what you're saying. Nice job. Nice job. So for what would x have to be in order to get y to be 1? It would have to be the square root of 8. Because now if I square that, I would get 8. Multiplied with 1/8, I would get 1. So the square root of 8, which you could put with your calculator real quick. Can you do that real quick? Is the same as 2 root 2, 1, 3. It's about 2 point what? Square root of 8, real quick. 2 point, anyone? Do square root of 8, control divide, control answer. So I can get a decimal answer. 2.828. So I should have gone 2.828 and then 1. And this right here should actually be my shape. It's a little bit better, but now this is the same as that distance better. Nice job. Go to lunch, guys. So, giving Joseph some mad props, what I've done is, during my lunch, I was thinking about this a little bit closer, and I have some questions for you. Awesome question, by the way. Awesome, challenging the thing. That's what it's all about, guys. I, too, can sometimes make mistakes and make me prove that it is correct. Don't just take it for face value, because I made a big mistake. So what I've done is I've erased everything that I made a mistake on, just real quick, and I will fix it with you as far as what you should have done. Now, we don't need to know this by hand per se right now of what I'm showing you, but the earlier that you do, the more masterful you're going to be at. And hence, props to you guys. That's why a lot of the class's tests were, on average, 3 to 4 points higher than normal. Okay, because you guys are really, really doing well right now. All right. So how could we graph this? We found A. And how could we graph this by hand? I said go up 1 over 8. And I was way wrong. I was way wrong. And this is what you should have done. First of all, I'm going to go back to Joseph. I'm going to ask him, what is it about this equation that tells me I can't do that? I used to be able to do that with absolute value. But I can't do that with this one. What is it about this equation that tells me I can't? Or anyone, if anyone knows. The squared. Because before, when I had the absolute value, this was to the power of 1. Okay, so it was a linear, not changing the way a parabola changes. You see what I'm saying? It doesn't have a constant slope per se. This has a constant slope. Not because this is 1 in front, but because of this right here. If it's to the power of 1, it has a constant slope. This just tells you what is that slope. See, this is x squared. It doesn't have a constant slope, so you can't do up 1 over 8. So if I wanted to know how to graph it, this is the way I would want you to go and solve about it. You're still going to go up 1. But the way I'm wanting you to go from the vertex is this equation, the y value would become 1. This is the up 1 that I'm talking about. And then work backwards. Multiply both sides by 8. Square root both sides. And this is how we got the 2.828. So at 1, 2, 2.828, which is about here, I should be at a y value of 1. That is how I get how far did I go out with the rise of 1. So when I draw it, it looks like this. Okay? Which, of course, again, this is the same distance that this would be right here. From the focal to the directrix. Questions? Okay, so I have the focus, and this we're about to do this next problem. I'm going to stop the video. I'm going to create another one that just shows examples of us doing this together, so that'll be on another video. I'm looking for the focus. I'm looking for the vertex. I'm looking for the directrix. I'm looking for the graph. Just everything that you know, what I'm going to be bonus pointing up here in just a bit. So that, looking for this, looking for the line, looking for the graph, and the A or P value in the equation itself. About 6 parts for each question is what I'm looking at. Any questions before we start?
Can we always be given the vertex and the focus?
So here's the thing. Let's say that I wasn't given, this is a really good question. Let's say I wasn't given the vertex and the focus. But I was given the focus and the directrix. Could you find the vertex? Yeah, just split the difference, right? You with me? But the harder ones, the hardest ones, won't necessarily give you these two pieces. The hardest ones will either give you a vertex and a point on the graph, or the focal point and a point on the graph. There's a lot more math involved in that, and you will have one of those today. Okay? Any other questions before we start for group bonus points? Because I'm wanting to get maybe 4 of these done. Okay, so I'll stop this video.